So you want to learn how to remember exact ratios for your trigonometric functions. I had friends at school who memorised tables upon tables full of them. Very complicated and a real fiddle. Let me show you a simple way to draw diagrams and remember them. Whenever you go to a mathematics examination, you're allowed to take your geometric equipment with you. And included in that equipment usually are two set squares. There's one like this that has two 45-degree angles, and there's one like this that has a 60-degree and a 30-degree angle. And these in fact are the two triangles we need to study. So just the fact that you have them as tools that you're allowed to take into the exam room is handy. In fact, if you have one like this, you might notice that you can even use the insert or the outside to draw the triangle quickly and accurately to remind you. So let's study those two triangles now. The first one we're going to study is the 45-degree triangle. We always label the shortest side as length 1, and since it's a 45-degree triangle, this length is 1 as well because the triangle is isosceles. That is, if these two angles are equal in length, then the opposite sides must be equal in length as well. How do we know the length of this? Well, we use Pythagoras Theorem. Now, if you keep forgetting which square root or what length goes with this, then all you've got to do, once every afternoon for a few afternoons, is use Pythagoras Theorem to work it out. So if we call this length k, then k squared would equal 1 squared plus 1 squared. That is, the two short sides squared, add up to that, that's Pythagoras Theorem, add up to that squared. 1 squared is 1, 1 squared is 1, so k squared is 2. Now when we take the square root of both sides, strictly speaking we get plus or minus the square root of 2, algebraically, but we don't talk about negative lengths here. So this length is equal to the square root of 2. This means that if I want to study sine, cosine or tangent of this 45-degree angle, I can use this triangle to work out the values exactly. Sine 45 degrees is opposite over hypotenuse. Cos 45 degrees is adjacent over hypotenuse, which turns out to have the same value. And the tangent of 45 degrees is opposite over adjacent, which is 1 over 1, which is 1. Very, very simple. If you're in senior high school and been introduced to another way of measuring angles, that is radians, it's worthwhile learning to draw these triangles and writing the radian measure in. And the radian measure for 45 degrees is pi on 4 radians. Now if you haven't learned this yet, you can just ignore and pretend I didn't share that. But if this is relevant to you, do notice that the pi on 4 angle matches with the 45 degrees. They've both got a 4. And that's a simple way of remembering it. So pi on 4 goes with 45 degrees. So again, if you're writing this in radians, sine of pi on 4 radians will be 1 on root 2. Cos pi on 4 radians, 1 on root 2. Tan pi on 4 would be 1. There it is. The second triangle is quite an interesting one. Now, it's interesting because I hope you notice that 30 degrees is exactly half of 60. And there's a very good reason for that. If you drew a triangle that had all three sides of equal length, what would it be called? An equilateral triangle. that means all three angles will be the same size. They must add up to 180 degrees, so they must all be 60 degrees each. So the triangle that we're interested in is one that we get by cutting an equilateral triangle exactly in half. So we get a right angle at the bottom. This 60 degrees is split up into 30 degrees. And we now have a right angle at the bottom, and I hope you realise that this length equals that length. Now, in the triangle we're going to study, let's say it's this left-hand one, which looks like the set square, it's the 60-30 degree set square, we'll call the shortest side 1. Now, a lot of students get confused what the other two sides are, but if you see the whole equilateral triangle, if this length is 1, what's this length? It's also 1. So what's the whole length of the side? It's 2. And it's called an equilateral triangle because the three sides are of equal length. So if this is length 2, so is that, and so is this. So it's the hypotenuse that is 2 units in length, not the altitude. So how do we work out the length of the altitude? Again, we use Pythagoras' theorem. Look, I'll use h for height. That's nice and conventional. Remember that 2 is the hypotenuse opposite the right angle. So these two small sides, their squares must add up to this square. So h squared plus 1 squared must make 2 squared. So if you have trouble remembering what length belongs here, do this for a few days, just once a day. H squared plus 1 squared is not difficult. 2 squared, 2 times 2, 4. We take 1 away from both sides to get h squared equal to 3, and we take the square root. Now again, strictly speaking, algebraically, we have to accept plus or minus root 3, but we're only talking positive lengths in this triangle, so the length h is root 3. Again, if you've been introduced to radians, it's worth labelling this triangle in radians. 30 degrees is pi on 6 radians, 60 degrees is pi on 3 radians. How do I remember it? Well, the 60 goes with the 3 and the 30 goes with the 6. In other words, the 6 and the 3 pair up. From this triangle, we can write sine 60 degrees will be opposite over hypotenuse, cos 60 degrees, adjacent on hypotenuse, tan 60 degrees, opposite over adjacent, root 3 over 1, I won't write over 1. And we can do the same thing with the 30 degrees. Sine 30 degrees is opposite over hypotenuse. Cos 30 degrees is adjacent on hypotenuse. And tan 30 degrees is opposite over adjacent. No need to memorise them. If you learn to draw these triangles quickly, and when you don't have to use Pythagoras' theorem and you know what to write, you should be able to draw both triangles in under 30 seconds and probably even under 20. Fully labelled. And I would practice that for homework so that I know that at any time, if I need these exact ratios, I can just quickly sketch the triangle, label it, and derive any of these ratios I need. When you've done this sufficiently often on paper, you find that you can actually picture the triangles in your head and work out the ratios immediately. So, for example, if someone asked me sine 60 degrees, I would picture the 60-30 triangle. I know it's a 1, 2, root 3, and sine of 60 is root 3 on 2. And I can picture that so rapidly now because I've done this over and over again on paper. So let me encourage you to do that. I hope you've enjoyed the explanation. Thank you very much for watching, and please subscribe and remember to like and comment on the video as well. Thank you.